All right, let's talk a little bit more about this sample code in order to explore more about the characteristics of properties and methods. All right, so once I have this fi variable here for a file info object, then I can use it in order to access different properties. The nice thing here is that simply by creating a file info object and passing it the full path and name of the file that I'm interested in, which I did here, which calls this constructor and passes that string there, simply by doing that, then I have some ready-made properties in order to get information about the characteristics of the file. Unlike earlier programming languages, here I don't need to write any low-level file access information. I don't need to directly access the Win32 system API for reading files out on the hard drive system. It's real easy. It's built into file info. It's done. I can get on with my application. Now, by the way, this attributes property is a little bit different than any property that I've shown you so far. It's an enumerated value and contains a number of named values, all of which represent numbers, corresponding to various possible file attributes like archive, compressed, directory, encrypted, and more, depending on what kind of file this is. And you can look up all the details in the system.io.file attributes enumeration in the .NET Framework documentation. Properties of a class can contain any type of value, including enumerations. In addition, some, but not all, enumerations allow their enumerated values to be combined, so you can create property values that contain multiples of the enumerated values. And the attributes property works exactly like that. You can set the attributes property to be a combination of enumerated values using the OR operator. Okay, so just keep that in mind, kind of an advanced technique, but it's a really handy feature of enumerations. All right, so that's properties. Let's talk now about methods. You might need to interact with a class, causing an instance of the class to take some sort of action. And the file info class contains a copy-to method as one example. This lets you copy a file to a new location, optionally renaming the file. And that's exactly what I do here in this code. But first, in order to make sure that the directory exists, the code also calls the createDirectory method of the directory object. So this code is going to create a CMyDemo folder if it doesn't already exist. Now, something interesting about this, though, is that I didn't need to create an instance of this directory object. And this is where we get back into static and instance members. Members that are static work with all instances of the class, and instance methods work only with the specific instance that you use to call the member. Okay, so one example of an instance method is this length property. So this applies both to properties and methods. In this case, I want to retrieve the length or the size of a particular instance of the file info class, which relates to a particular file on the hard drive. So length is a characteristic of a specific file. Not all files everywhere. All files everywhere have a length property, but I want the length of a specific file. So as a result, this length property is an instance method of the file info class that's connected to that specific file. On the other hand, the createDirectory method doesn't apply to a particular directory. I'm not acting on a specific directory because the directory I want doesn't exist yet. Okay, so the createDirectory method is just a service provided by the directory object. It's a static method of the directory class. And when you create your own classes, you can specify any member as being static or not. Okay, and then once again, the copy-to method is a static method because I want to do something to a specific file. I want to take the file, read its contents, and copy it to another location. Okay, so because this is an instance method, I need an instance of the object in memory. And so I'm going to use this object that's related to the file that I want to copy. And then the return value of the copy_to method is a new file info object. Here I'm calling it new fi. And that's going to have a reference to that new file, not the win.ini file that this is referring to, but now the test.txt file that's in C/mydemo. Okay, another interesting thing about this code is that you might find it interesting or perhaps even confusing that this code uses the file info class along with the directory class. There's also a directory info class. So why does the framework include both the file info and file classes and the directory info and directory classes? Well, fortunately, there's a simple explanation. Both the file info and directory info classes correspond to a single specific file or directory. All their methods and properties refer to that specific file or directory. But the file and directory classes provide static methods that allow you to work with files and directories in general, without referring to a specific single file or directory. So, for example, system.io.file, that class provides a copy method, and you have to supply both the source and the destination file names, because the file object isn't holding a handle to a specific file on the drive. But system.io.fileinfo provides a copy_to method for which you only have to specify the destination. And again, that's what I did right here. That's because file info refers to a file. I already have the source file. I already have a reference to it. So all I need to provide is the destination. So I want to use file info and directory info when I want to perform multiple operations on the same file and directory. But I want to use file or directory when I want to perform a single operation on a file or directory, or when there's no specific file or directory that I'm already interacting with. Alright, so static and instance members are important. But how do you know which is which when you're investigating a new class and exploring its members in order to use it? Well, let's go back over to Internet Explorer and take a look at the documentation for the methods of the file object. So it's real easy to tell. This little icon right there with the S indicates that this is a static method, which means that I don't need to have an instance of the file object in memory before I can call this method. I can use it to access all kinds of different files in the file system. But then if I look at the methods for the file info class, notice that there's no S there. And if I scroll down, you can see that there are no static methods on this class. Now, that isn't to say that there couldn't be. You can have a mix of static and instance methods on the same class. In that case, you would have to instantiate the object into memory to use the instance methods, but you could use the static methods directly. And you can do that same thing in your own classes.